Video, we had to draw the shear force in the bending moments diagram for a simply supported beam with external moments. So first of all, we need to calculate the support reactions. This is a hinge support. So to give a vertical reaction, we call it VA. To give a horizontal reaction, we call it HA. This is a ruler. A ruler support has only one reaction. So we call this VB. You can call this side A and this side B. So let's make use of our equilibrium equations. So let's take moment about support A. So sum of moments about A is equal to 0. Taking clockwise moments as positive. So there's an existing moment. The 24 kilonewton meter is moving in the clockwise direction, so it's positive. So 24. 16 kilonewton is an existing moment and it's moving in the anti-clockwise direction, so it's going to be negative, so minus 16. VB will cause an anti-clockwise moment, so it's going to be negative, so minus. So VB times the perpendicular distance from where VB is acting to where I'm taking the moment, and that's 10. So it's going to be 10 times VB. So these are the only forces that will cause moments. VA will not cause any moments because S line of action passes through where I'm taking the moments. Everything here is equal to 0. So let's make VB the subject. When you move 10 to the side, you're going to get 10 VB is equal to 8. And we divide through by 10. So VB will be equal to 0.8 kilonewton. So that's the vertical reaction, VB. So let's calculate for VA. So sum of vertical forces is equal to 0. Let's take upward forces to be positive. VA is moving up, so it's positive VA. VB is moving up, so positive VB. These are the only vertical forces, so we equate this to 0. So VA is equal to negative VB, and we already know VB, so this means that VA is equal to negative 0.8 kilonewton. So that's VA. Now let's find HA. So sum of horizontal forces is equal to 0. Let's take forces moving to the right as positive. HA is moving to our right, so it's positive HA. That's the only horizontal force, so it's equal to 0. We are done calculating the support reactions, so we can calculate the shear force. So the shear force, so calculate two shear forces at A. So shear force at A prime is equal to 0. And the shear force at A is equal to 0 plus. So plus because VA is moving up. So the value for VA is negative 0.8. Because it's moving up, it's positive, so plus VA. But VA is negative 0.8. And this will give us negative 0.8 kilonewton. That's the shear force at A. So the shear force at B, also calculate two values. So shear force at B prime is equal to negative 0.8 kilonewton. That's our previous one. Shear force at B itself will consider the force acting at B. This is going to give us negative, the previous one, negative 0.8 plus VB. So plus VB. But we know the value for VB. Negative 0.8, and we know that VB is 0.8. It's going to be plus 0.8. And this will give me 0. So that's it for the calculation of the shear force. So we can now draw our shear force diagram. So this side is A and this side is B. Shear force at A is 0, 0 here, negative 0.8. So 0 here, negative 0.8 can be somewhere here, kilonewton. So connect these two. The shear force at B prime is also negative 0.8. So negative 0.8 kilonewton. And shear force at B is 0. So we connect these two and connect this and this. So that's the shear force diagram, and it's all negative. Now let's deal with the bending moment. So the bending moment at A. Let's take our left. So we'll take moment to our left and call it BMA. So it's negative BMA because it's moving in the anti-clockwise direction. Anti-clockwise. And 16 kilonewton is also moving in the anti-clockwise direction. So that one will be minus 16. So these are the only forces that will cause moment at E. Everything here is equal to 0. When I make BMA the subject, BMA will be equal to negative 16 kilonewton meter. Now the bending moment at B. So because I want to take my right, I'll take moment to my right. And I'll call this BMB. So moving the clockwise is positive, so BMB, positive BMB. 24 kilonewton meter is moving in the clockwise direction. So that's going to give us plus 24. It's already a moment at 24. These are the only forces that will cause moments. Everything here is equal to 0. So BMB is equal to negative 24 kilonewton meter. So these are the calculations for the bending moment. So we can draw our bending moment diagram. This portion is A and this portion is B. Bending moment at A negative 16. So negative 16, we can bring it here, negative 16 kilonewton meter. Now connect the two. Bending moment at B negative 24. So negative 24. So B will stand here, then you move up to negative 24. So negative 24 will be here. So negative 24 kilonewton meter. So you move down 24 kilonewton meter. And here is 16. And after that, you join the two. It's all negative. This is the bending moment diagram. Thank you for watching this video.